Welcome to your favorite inorganic tutor. Today we want to look at some series of questions. Probably they are your quiz questions, the Mat101 first quiz. So these are your first quiz questions and answers. All right, so I want to answer your first question for you. Please don't forget to subscribe as well as share to your friends to also benefit from this. All right, so let's continue. Our first question is, he said we should find the Cartesian product of z times, that is, the z is integer, right? Z times n intersection n times z, right? Where n and z are natural numbers and integers respectively. All right, so from here we can see that this, when you do this intersection, your answer will be this. All right, so we say that z integer times a natural number intersection a natural number times an integer, we will have an integer, we have a natural number times a natural number. All right, so that will be your solution for this question, where they said you should find the Cartesian product of z times n intersection n times z, where n and z are natural and integers respectively. All right, so our answer is n times n. All right, n times n. All right, and the next question is, which of the following statement is true? It's not true for the set of whole numbers. Which of the following statement is not true for the set of whole numbers? All right, and our first option was a plus b can be equal to b plus e. All right, and then b minus a minus b can be equal to b minus a. All right, and then ab can be equal to ba. All right, and then they also said a plus b plus c, that's distribution, or this is associative, can be equal to a plus b plus c, right? And looking at this, they said which one is not true. All right, so this, which option do you take from this? We say that the b is not correct. All right, so a minus b cannot be the same as b minus a. Maybe you're having a to be 3, b to be 2. If you say that a minus b is equal to b minus a, it's not right, because 3 minus 2 is 1 and 2 minus 3 is minus 1, so that is not right. So we say that the option b is wrong. All right, so which of the following statement is not true for the set of whole numbers? A minus b is not equal to b minus a. All right, so option b is wrong. Third question, they said if in a, b, and c, the set b intersection c consists of 8 elements, a and the set a intersection b consists of 7 elements, and the set a intersection c consists of 7 elements, find the minimum element in the set. So what they are trying to tell you that is to find the union of the set. This is a 3-set problem. All right, so our intersection is 7. Our intersection for all the 3 elements is 7. All right, and we are having a intersection b to be 7. So if the intersection is 7, when you subtract 7 minus 7, you get 0. All right, so our union will now be a intersection a union b union c will be equal to 0 plus b intersection c was also given as 8, right? So we have 7 8 minus 7, that gives us 1, all right, plus the intersection itself, plus the next set, which they gave us 7 elements for A intersection C, all right, and that is also 7 minus 7, all right, and that will be 0. So when you add all these elements, you are getting 8. So that will be our minimum element in the set. So that's basically what they are trying to look for in this question. So our answer over here will be A. All right, very, very easy. If you don't understand this statement, you end up getting this question wrong. So our answer towards this question is option A, which is 8. All right, and the next question says, identify the statement 0.1035 up to infinity is an irrational number. All right, and they are saying that A, sometimes, B, always, C, never true, and D, not sure. So 0.1035, you know that it's always an irrational number. So you don't have to think too much about this before you circle your correct answer. All right, so we say that the value 0.1035 is always an irrational number. All right, so our option B is correct for this question. All right, very, very simple. Very, very simple. So 0.1035 is an irrational number, and it always remains an irrational number. You cannot do anything about that number. All right, and then our question 5 is, which of the following is not an equality property? Which of the following is not an equality property? All the properties over here are making sense, but which one is not an equality property? All right, so over here we can see that this property, the distributive property, is not an equality property. We have symmetric here, we have reflexive here, we have distributive. This reflexive, distributive, reflexive, transitive, and then the symmetric, they are all equality property, but with the exception of the distributive property, it's not. All right, so our answer over here will be the distributive property, the option A. All right, our question 6 also says, for any two given real numbers, A and B belongs to the real number system, which of the following statements may not be true? Which of the following statements may not be true? All right, so we can say that A is equal to B, and we can also say that A can be greater than B, and we can also say that A can be less than B, but we cannot say that A is greater than or equal to B. It's never true. So we say that option B is wrong. All right, so we say A cannot be greater than or equal to B, but we can say that A is equal to B, or A is greater than B, or A is less than B. That's the only thing we can say about this statement. All right, so let's look at our next question over here. It said we should simplify this expression P intersection Q prime union P intersection Q. All right, P intersection Q prime union P intersection Q. And you know that union is what? Addition. Union is already addition. So what you do is that P intersection Q prime or P intersection Q. This, what you must let it come into your mind is that Q prime and Q is like positive and negative. So this and this will go. All right, and then you have P intersection P. All right, so your answer will be this P. Okay, B intersection P. B intersection. Now this, you don't have anything here, so it will be P or P, and that will be P. Alright, so simplifying P intersection Q prime union P intersection Q, your subset of the universal set U will be P. Alright, and then our 8th question is, that is where I have to stress more on it. Maybe you may have similar question in your exams. I don't want you to get it wrong, so please focus on this question. They said we should solve the inequality, and here lies the case. They gave the inequality absolute 4 minus x, alright, should be less than -3. But here lies the case. Do you have an absolute number that is less than negative number? Note, we don't have an absolute number. When the moment you say the word absolute, it must always be a positive number. Alright? So from here, we must note that the absolute value of any real number, the absolute value of any real number is always non-negative. The absolute value of any real number is always non-negative. And therefore, the expression 4 minus x, the absolute of 4 minus x, cannot be less than -3. However, if we assume that x is a real number, then the absolute value of 4 minus x will always be a non-negative number. And it cannot be less than -3. Note that it cannot be less than -3. So the inequality absolute 4 minus x should be less than -3 has no solution in the real number system. It has no solution in the real number system. So we say that absolute 4 minus x less than -3 is empty. It has no solution in the real number system. Alright? So we with regard to this question, the value or the answer for this question is empty set. Alright, because the absolute of a number should not be less than or should not be equal to a negative number. So that's it for this question. Alright, thank you very much. Alright, so question number 9 says, or this preamble says, we should, a quadratic function f of x has zeros m plus 1 over n and n plus 1 over m, where m and n are root of the equation s squared minus bs plus q equals 0. They said we should use the information to answer question 9 to 11. Alright, and the question 9 says we should find the sum of the root. Alright, the sum of the root. So this, our answer is a minus b over q plus what? Q. Alright, but let's look at how it came about. So they gave us the function s squared minus bx plus q equals 0. Alright, so let's compare this with the original quadratic equation, where it is s squared plus bs, as squared plus bs plus c equals 0. So here we say that our a is equal to 1, our b is equal to minus b, and our c is equal to what? Q. Alright, so once we have been able to find the a, b, and c, we can now find the sum of the root. Alright, so sum of root is equal to minus b over a, and that is minus b, which is the b is already minus p, so it's going to be p over the a, which is 1, and that will be p. Alright, and the product of root is equal to c over a. Alright, and the c over a, we know that c is q. and the A is 1, so it remains Q. All right. So from there, we can say that. They gave us the roots, the zeros as m plus 1. So we find a new sum of roots, and that will be m plus 1 over n plus n plus 1 over m. So adding these variables nicely, you have m plus n plus 1 over m plus 1 over n. All right. So we gently do this. You have n plus m over mn. All right. So from here, we can now put in the sum and then the product. All right. And the sum we had P. So you have P plus the sum again at the top, P over the product, which is the Q. All right. So from there, we can now find, or we can now sum this, simplify this. All right. So simplifying this, we have over Q over here. So we have this minus P. So we have minus P into Q plus 1. All right. So over here we have minus P into Q plus 1, and that will be our final answer. As we obtain in as the option A. All right. Very, very simple. It's about you understanding the concept. If you understand the concept, you know what you will do. All right. So it's very simple. That is what we've done over here. So our answer is A, minus P into 1 Q plus 1 over Q. And the question then says we should find the products. So 10, find the product of the roots. All right. But now we have the sum already. We have the sum already as 1 over m plus 1 over n plus comma m plus n. All right. So this we have 1 over m plus n multiplied by 1 over n plus m. All right. So this, when you do this, you have 1 over mn plus m over m plus n over n plus mn. All right. So from here, we can now say that 1 over mn plus 1 plus 1 plus mn. All right, and this will be 1 over mn plus mn plus 2. All right, and we already know the sum and then the product. We just have to fix in the variables, and then we are there. All right, so we now put in the variables, and then we can get the product of the roots. All right, so we say that where minus b over a is equal to minus p. All right, and then c over A is equal to Q. Alright, so from there we can say that we can then put them into the expression obtained. I mean, this is the product. I already told you that if they give you a question like this, you can get product of root inside, you can get sum of root inside. Alright, so that is what basically we are doing. Alright, that is what we are doing here. So we have 1 over m, which is mn, which is the q, plus 2 plus the mn again, which is the q. Alright, so this, simplifying this very well, you have q squared plus 2q plus 1 all over q, all over q. So that will be our answer for this question. The question 10, find the product of the roots. That's be our answer. Q squared plus 2q plus 1 all over q. Alright, so let's move to the next preamble. He said we should find the 11, we should find the equation whose roots are m plus 1 over n, and then n plus 1 over m. Alright, the same question that we were given from the previous discussion. That is the same question we are using to solve about 3 questions now. Alright, so take note. So then the options given were A, s squared plus q plus 1 all over b multiplied by x plus q squared minus 2q all over q plus 1, and then b s squared plus p into q minus 1 all over q multiplied by x plus q squared minus 2q plus 1 all over p should be 0, and then c s squared plus p into q plus 1 all over q all by x plus q squared plus 2q plus 1 all over q should be equal to 0. And then the last part of the solution, which is s squared plus p into q minus 1 all over q by x plus q squared plus 2q plus 1 all over q should be equal to 0. So looking at what we've already done, we can boldly say that our option or the correct answer is C, s squared plus p into q plus 1 all over q multiplied by x plus q squared plus what? Q, 2q plus 1 all over q. Alright, should be 0 because the sum we have this and then the product we have this. Alright, so we just combine them. Alright, we just combine them because you know that the equation formula is s squared minus sum of roots times x plus products of roots, alright, should be equal to 0. Alright, and then the sum of roots, we obtain this part to be negative. That's why we are having positive over here. And then the product is already there. We obtain it here. Alright, we already obtained the sum as well. So we just fix it into the formula and then we are there. You don't need to be struggling to be solving for this and that again. So the question is all about you being smart. You don't have to solve each of the questions before you get the answer. You see, this question like this, it was following a format. Question 9 was following question 10 and question 10 was following question 11. And then the question 11 itself was combining question 9 and question 10. So you have to if you get the question 9 and 10 wrong, it means you are getting the 11 wrong as well. So please don't forget to check the solutions or your way of solving the questions well. All right, so let's move to the next question. Question 12. Question 12. Question 12. Question 12 says, or this is the preamble. They said the root of the equation 3x squared plus 4x minus 5 is equal to 0 are alpha and beta. It said use the information to answer question 12 to question 14. Alright, so this question like this is following a format like we just did. Alright, so question 12, they said we should find the value of 1 over alpha plus 1 over beta. Alright, they said we should find the value of 1 over alpha plus 1 over beta. And these are the options. A is 4 over 5. B is minus 4 over 3. C is 2. D is minus 4 over 5. Alright, so let's prove. the correct answer is 4/5, but let's prove. So we were given a quadratic equation 3x squared plus 4x minus 5 equals 0. So we compare this to the general quadratic equation 3ax squared plus bs plus c. So from here we see that our a is equal to 3, b is equal to 4, and c is equal to minus 5. Alright, so once we have been able to obtain the value of a, b, and c, we can now go ahead and find the sum of roots. So we say sum of roots, which is equal to minus b over a is equal to minus 4 over the a, which is minus 4 over the a, which is 5. All right, and then the product is equal to c over a. All right, and that will be minus 5 over the a, which is 3. All right, so that's it. That is it for (4 over 3). And then we can say that we can find the new sum of roots. So the new sum of new roots would now be equal to what we were given. They said we should find the value of 1 over alpha plus 1 over beta. So that would be 1 over alpha plus 1 over beta. So finding this, the sum of this, we get beta plus alpha over alpha beta. All right. So this, we can now go ahead and put in the value of the beta plus alpha and then the alpha beta into the expression, and then we get our value for the value of alpha plus 1 over alpha plus 1 over beta. So this we have minus 4 over 5 all over minus 4 over 5 all right. So from here we can say that this is equal to minus 4 over 3 times 3 over minus 5. All right, and this will give us 4 over 5. All right, so let's get to the 14th question. Our 13th question says we should find the value of alpha squared plus beta squared. So this, we've confirmed this over here, 4 over 5. And then alpha squared plus beta squared, we can simplify this alpha squared plus beta squared. And you know that alpha squared plus beta squared is equal to alpha plus beta all squared. All right, so this alpha plus beta all squared can be written as alpha squared plus beta squared plus 2 alpha beta. All right, and we need this, so we bring this here and then maintain that one there. But we already know the value of alpha plus beta. All right, So we just put in the values and then we go away. So we have minus 4 over 3 all squared is equal to alpha plus beta. Alpha beta will give us minus 5 over 3. So 2 over minus 5 over 3 plus alpha squared plus beta squared. Alright, so now our alpha squared plus beta squared is now giving us 4 squared 16 over 9 minus, that would be plus 10 over 3, and this will yield 46 over 9. Alright, so per the options given, A 16 over 9, B 10 over 3, C 46 over 9, D negative 4 over 3. So we can see that our correct option is obtained over here as 46 over 9 obtained over here. So let's look at the last question, the question 14. The question 14. The question 14 says we should find the value of alpha over beta plus beta over alpha. Alright, so this thing, simplifying this thing, you have to simplify this, find the LCM for this, and then you can then go ahead and then put in your values. So this, you have alpha squared. When you find the LCM for this, you have alpha squared plus beta squared all over alpha plus alpha beta. Alright, and this, you already know the value for this, so you don't have to stress yourself. So we can say that from question 13, alpha squared plus beta squared is equal to 46 over 9. So we just fix in the value of that, and then we go away. So you have 46 over 9 all over the alpha beta, which is minus 5 over 3, and this gives us 46 over 9 times 3 over minus 5, and this will finally yield minus 46 over 15. Alright, so this is basically the final answer for that. From what we did last yesterday, our question number 14, the answer is B, minus 46 over 15. Alright, so we are looking at the question, this preamble. It said, given that P of X equals this, use the information to answer question 15 and 16. Alright, so it's the answer where is B, which is 2. So let's look at how we go about it. So P of X is equal to S cubed minus 4S squared plus 2S plus 3. Right, so having this, they said is divided by X minus 1. Alright, so this X minus 1 S cubed minus 4S squared plus 2S plus 3. Alright, so use this to divide every expression under the root sign, and then this divide this, you have S squared, then use it to multiply. You have s squared over here, s cubed minus s squared. Then you subtract. All right, subtract. You get minus 3s squared plus 2s plus 3. All right. So from there, you go again, get minus 3x, and then use it to multiply, get minus 3s squared plus 3x. Alright, continuing this procedure, you have go back again with the same procedure. So this, you subtract again, then you go back. Are you getting it? So you subtract, you have minus x plus 3. Alright, then you use this to multiply again, then you have minus 1. Use it to multiply the whole thing, you have minus x plus 1. Right, so this you subtract, you have plus 2 as your remainder. So this is our remainder as the question demanded, and we've proved it. Alright, so this is B. So let's go to question 16. So we should find the remainder when b of x is divided by s plus 2. So the same function, but we are dividing by x plus 2. Alright, so from here, b of x is divided by s plus 2. So s plus 2 root of s cubed minus 4s squared plus 2s plus 3. Alright, so this you divide by s plus 2, and then you go by the same procedure again. We have this divide this, you have s squared, then use it to multiply the whole thing. You have here, you have s cubed plus 2s squared. Subtract. Alright, you subtract, you have 2s squared plus 2s plus 3. Go back again, so because you are still having in terms of x, so you go back again, subtract, you have plus 2x, multiply back again, you have 2s squared plus 4x plus 3. Alright, so same procedure, then you have minus 2x plus 3. Then you go back again, divide this, get minus 2 times this, get minus 2x minus 4. Alright, so you do that diligently, and then you have minus 1 over here. So as circled B, you have minus 1 as your answer, and it's proven. So in case you have similar work in your exams, this is how you go about it. Let's look at the question 17. It said the expression s cubed plus 4s squared plus as plus b is divided by s squared minus 1. The remainder is 2x plus 3. Alright, so we should use this information to answer question 17 and 18. So let's look at how we go about that. So s cubed plus 4s squared plus as plus b is divided by x squared minus 1. So if it's divided by x squared minus 1, as usual, go by the same procedure. X squared minus 1 is x minus 1 and then x plus 1. So you go by the same procedure, and they have two equations. solve them simultaneously, and then you obtain the value of a and b. So s minus 1, then you have s cubed plus 4s squared plus as plus b. Alright, you do this, and then you do that of x plus 1 with the same equation, s cubed plus 4s squared plus as plus b. So what you have, the equations you have here and then here, you solve them simultaneously, and then you obtain the value of e and b, and that a is 1, and then question 18. Question 18. Section 5. Value of b. So the options here are minus 1, 0, c, 1, and d, 2. Right. So our value of b as well is minus 1, as we clearly explained over here. Use this to divide, have an equation in terms of a and b, and then use this to divide, have an equation in terms of a and b, and solve them simultaneously, and then you have the value of a and b. So the value of a is minus 1. All right. So 19, we have to form the polynomial equation whose zeros are 2 plus 1 over x, and then 2 minus 1 over root of x, having options as s squared minus 3x minus 1, b 2s squared minus 8s plus 7, c 2s squared plus x minus 2, and then d s squared plus 5s plus 1. This we have to form the polynomial whose zeros are this. So all we do is that we find a sum, and then we find the product. All right, and we already do the general equation for the polynomial x squared minus sum of roots times x plus product of roots should be equal to 0. So when you have something like this, all you have to remember first is the formula or the equation of the general equation of the polynomial, which is x squared minus sum of roots x plus product of roots equals 0. So from there, you know that our sum will be, this is 2, we know that our sum will be 2 plus 1 over root 2. This is 2, and this is also 2, plus 2 minus 1 over root 2. Alright, so when you sum this very well, you have 4. And then we look at the product aspect as well. So the product of roots as well is 2 plus 1 over root of x, and then 2 minus 1 over root of x. So this, multiply this very well, you have 7 over 2, right? This multiplies this, this multiplies this, this multiplies this, and then this multiplies this, and at the same time this also multiplies this. So looking at our general formula, when you put them inside, you have x squared minus 4x plus 7 over 2 is equal to 0. Alright, so you can decide to eliminate the fraction by doing 2x squared minus 8x plus 7 is equal to 0. So this correct option will be option B. Right, very, very easy. Our last question will be this. Set let x, y, and z be sets. Set that y is a subset or equal to x, which of the following is true? So we have A, S union Z is equal to U, Y union Z is true. B, x intersection Z is equal to x intersection Z is a subset of x prime intersection y prime. And then C, we have x intersection Z is equal to y intersection Z. And finally, x intersection y union Z should be equal to y union x intersection Z. So looking at this set, our right option will be option D. But this complement is never equal to this. This is also never equal to this. And this is also not equal to this. So our right option is option D. Alright, so thank you very much for watching. Don't forget to subscribe to an Inorganic Tutor YouTube channel, and we'll upload more questions and answers to help you prepare for the quiz and your exams as well. Bye.